Hello, I am your host today, and welcome to the Animated Scholar. You've probably been told your whole life that you just can't take the square root of a negative number, right? Well, today, we're going to break that rule. We're about to dive into the absolutely fascinating world of complex numbers, a hidden dimension of math that's way more powerful than you might think.
So, take a look at this. This isn't just some boring worksheet. Think of it as our treasure map. Every single question is a clue, and each clue is going to lead us closer to unlocking the secrets of complex numbers. And don't you worry, we're going to solve every single one of these puzzles together, step by step.
Here's our game plan for today. First, we'll decode what complex numbers even are. Then we'll pull out a special map to see where they live. After that, we'll get our hands dirty and actually crunch some numbers. And then we'll put all those skills together. And finally, you'll get your chance to crack a final challenge all on your own.
All right, let's kick off our journey by tackling the very first clue. What is a complex number anyway? This is the foundation, the basic blueprint for, well, everything else we're about to do.
Okay, so a complex number is kind of like a superhero with a secret identity. It's got two parts. You have A, that's the real part, the everyday numbers we all know and love. Then you have B, the imaginary part. That's the superhero's secret power. And it always comes with its trusty sidekick, iota. So here's our first real puzzle from the map. We're talking about real numbers, like 5 or -10. But what if I told you they've been living a double life? What other kind of number are they, really? Take a second and think about it. And if you guessed complex number, you nailed it. This is such a cool insight. Every single real number is really just a complex number in disguise, one where the imaginary part, b, happens to be 0, so the number 5 is actually 5 plus 0 times iota. It's like finding out your favorite superhero's secret identity all along. Right, so it's this two-part team-up that is the whole secret sauce. You've got the real part and the imaginary part, and they work together. As we're about to see, together they pinpoint one single, unique spot in a very special kind of space. Okay, so if these numbers have two parts, where do they actually live? Well, it's not in some weird abstract world you can't see. It's on a visual map, one that you can actually draw and navigate. Let's go check out the Argand diagram. So our map asks, what's the official name for this map? We've got a few options here. Is it a vector diagram, a Venn diagram, or something else entirely? You got it. It's an Argand diagram. And honestly, it's way simpler than it sounds. Just picture a regular city map. The real axis is the main street that runs horizontally, east to west. And the imaginary axis is the cross street, running vertically, north to south. Every complex number has its own unique address right there on the map. And this map is so much more than just a picture. It's a really powerful tool. It shows you exactly where the number is. The real part tells you how far to walk along the horizontal street, and the imaginary part tells you how far to go up the vertical one. It even shows you the number's magnitude. That's just how far it is from the center of town. And its conjugate, that's just its perfect mirror image, right across that main real street. All right, we've got the lingo down, we've got our map. Now it's time to actually do some math. This is where the real fun begins, so let's get to it. Whoa, okay, take a look at this thing. It looks like a monster, right? This long chain of iotas raised to all these different powers. It looks pretty intimidating, I know. But like any good puzzle, there's a hidden pattern inside that makes the whole thing just fall apart so beautifully. So here's the trick, and it's super cool. The powers of iota just cycle through the same 4 values over and over and over again. So iota squared is -1, and iota to the 4th is +1. And when you add those two together, you get 0. Every single pair in this long chain just cancels each other out perfectly, and the entire thing just collapses down into a big, beautiful 0. And hey, remember that conjugate we talked about, the mirror image on the map? It's not just for looks. It's an incredibly powerful tool. It's like having a secret key that unlocks complex division, letting you turn a messy denominator with an iota in it into a nice, clean, simple real number. Okay, deep breaths. We've handled the basics. Now we're going to put it all together and tackle some of the trickier puzzles on our map. This is where we really start to see what these numbers can do. Now check this out. In the world of regular numbers, trying to factor a sum of 2 squares is, well, it's impossible. But with our new secret weapon, complex numbers, the impossible suddenly becomes possible.
How do you think we can crack this one?
The secret? It's our new best friend, iota. It's the magic ingredient. We can do this clever little trick where we rewrite a plus sign as a minus negative, and that lets us use iota to turn a sum of squares into a difference of squares. It's just a brilliant example of how complex numbers solve problems that are totally unsolvable in the real world.
Okay, this next one looks a little scary, I'll admit. But trust me, don't let it fool you. This is really just a classic algebra problem wearing a clever disguise. We're still just solving for a variable. It's just that this time, our variable happens to be a complex number. All the same rules still apply.
Wow, we have covered a lot of ground. We've cracked the codes, we've navigated the map, and we've crunched the numbers. Now it's time for the final test. Are you ready to show off your new code-breaking skills?
All right, this is it, your final challenge. This is a real test of everything we've learned. So go ahead, pause here, and give it your best shot. And hey, don't be surprised if the answer you get looks a little complex. So, what did you get? Please give your opinion in the comments section. Do like the video and share it with your friends. Last but not least, subscribe to The Animated Scholar.